Welcome, everybody, to Chill Skills Sporlan Tech Talks. The topic for this episode is refrigerant retrofits. Here's a shameless promotion for the next webinar we plan to do in June 18th, 2020. We will continue the discussion on metering devices that goes along with the supermarket seminar series. We'll focus on refrigerant distributors during that webinar. Now, here are just a few simple instructions. If the speaker on your computer doesn't work, you could simply dial in with your phone. There should be a phone number somewhere on the invitation that you originally received for the webinar. And please mute your microphone. Might not be needed because we tend to be able to do that remotely, but just to make sure. As we move along and you have questions, you could type those questions into the Q&A window. As best we can, we'll deal with some of those questions live. But we're likely to run out of time. And during the course of the webinar, if we can, we'll post answers, but eventually we're going to have a posted online Q&A blog. And you never know, we may answer your question during the course of this webinar in and by itself. The recorded version of this will appear first on Facebook Live for your listening enjoyment, and later on the Sporlan YouTube channel. Hello, I'm Jim Jansen, the good-looking guy on the left, Senior Application Engineer for the Sporlan Application Team. And joining me today is Heath Schaefer. Heath is the Product Manager for Electronic Controls. He also collects a paycheck from Sporlan. He's the smart one of these two. Somebody really needs to be. Why don't you say hi, Heath, so everybody knows you're here.
Hello, everyone. And just so you all know, Jim does get his left and right mixed up. So the good-looking guy is,
on the right. Oh, I see how you're going to be. Hey, and you know what, Heath, we got a special guest that's joined us.
Yes,
we don't have his image up here. It's Mr. John Whithouse. John is in the room. John is our Senior Principal Engineer. He's a published author, consultant, and all-around extra smart guy. Thanks for joining us, John. You can say hi if you'd like.
Good afternoon and hello, everyone.
Yeah, don't know if they heard you, but it's a good try. Phyllis is also in the room. She's our communications director. She tells us what to do and when to do it, and occasionally we'll listen to her. If you have any follow-up questions or feedback for us, you can contact us via the email that's listed under each one of our names, or you can contact SVD Tech Support at parker.com directly. You can also call 636 area code 239-1111 for our general headquarters number, or you may call tech support directly by dialing 636-392-3906. You'll see that information again at the end of the webinar. If you've been following along with our supermarket seminar webinars, you know that we've been discussing metering devices. Those are those contraptions that meter refrigerant flow to the evaporator and control things like superheat. While this episode of Chill Skills is not necessarily part of the supermarket series, it does deal somewhat with metering devices and some of the other components that should be evaluated during a retrofit project. During a retrofit project for refrigerants, there are many concerns. If we take a look at the slide here, you'll see things like concern over elastomer seals that may deteriorate and leak. That mass flow rate and capacity may change. Mineral oil to POE oil or lubricant contamination may occur. Retrofits likely affect suction line sizing, compressor sizing, evaporator pressure regulator sizing, thermostatic expansion valve, and distributor selection, and even thermostatic element selection. Any one of these listed concerns could be the subject matter for a complete webinar in and by itself. But we will first take a look at the details involving the mechanical flow controls, and we'll provide a few examples to consider and the required evaluations for refrigerant applications. But we will not be discussing every single refrigerant option that's out there. Those options seem to change almost daily. Then at the end, towards the end, Mr. Heath here will discuss an electronically controlled, actuated, I need to go back to school to work on my pronunciation, controlled option for you to consider, and it really is pretty cool. When we start to consider valves and controls for these refrigerants, particularly in the case of system retrofits, one of the first things we need to consider is the capacity of the refrigerant relative to ones we are replacing. The top chart here shows net refrigerating effect, or NRE, for R22, R404A, R407F, and R448A at a few different low temp and medium temp conditions. The lower chart is the resultant mass flow of each that we need per ton of capacity. There are, let me back up here a minute, there are a lot of numbers up here. So let's look at some trends and similarities. We find that R22 and 407F are very similar in terms of NRE and mass flow. R448A mass flow is 7 to 10% higher mass flow than R22. And the mass flow required for R404A is significantly higher than the others. That's very interesting, don't you think, Keith?
Yes, sir.
That would be the case. Now, before we get into the nitty-gritty of sizing and selection, we should talk about guidelines. And I'm not talking about hard rules, not hard rules, but suggestions, guidelines for things like distributors and thermostatic expansion valves. We're also going to define medium pressure refrigerants as including all the ones we are discussing today, and those similar in pressure to things like R22, R404A, R507, the 407F series, 448A, and the like. Now, in the distributor tube assembly, flow is driven by our high to low side pressure difference, delta P, if you will. In general, greater delta P means more even distribution to the coil circuits. In a new system design, Sporlan guidelines call for 10 psi drop through the tubes and 25 psi drop across the nozzle. Those guidelines also tell us that 50 to 200% rather, as calculated by our selection program software, is acceptable. For our discussion, we're going to try to stay within 30 to 60 psi total delta P for low temp systems and 20 to 50 psi for medium temp systems. Many distributors do have replaceable nozzles, but they must be unsweated from the valve to change that product. But what I want to stress here is that we must know what's going on in the distributor to accurately select the expansion valve, because flow through the expansion valve is driven by delta P that we've already used in the distributor. We'll use guidelines of 50 to 80% loading for conventional thermostatic expansion valves and 35 to 80% loading for balanced port construction and thermostatic expansion valves. With thermostatic valves, over 100% loading is possible because we build some contingency into those products. But that's not recommended necessarily in refrigeration applications. And for the most part, that's what we're dealing here. You could extrapolate this to air conditioning situations, but for the most part, we're considering a refrigeration application like you'd see in a cooler or a case in maybe a supermarket environment. Electric valves, we can increase that range to 20 to 80% for both stepper motor driven and pulse width modulating style valves. With electric valves though, 100% loaded is generally considered to be the maximum possible flow through the valve at the conditions specified. There's no reserve built into these products as there is with some of our expansion valve line in the thermostatic range. With some guidelines to follow that we've now kind of put in place, let's jump into a theoretical retrofit. We are considering a retrofit on an R404A system here, and we're looking at a 1-ton load on a low temp system. Using the Sporlan selection program, we select an R404A distributor and a TEV. We select a number 2 nozzle assembly like you see here, giving us 41 psi total delta P, distributor and tubes. Using that number and assuming a 5 psi drop through the high side lines, we have 192 psi drop across the TEV. That's the number you see here. A 2-ton type SCS-FB valve, which is one of the products you might encounter in a supermarket installation, is 64% loaded at these conditions. We would use the S as in Sam, Z as in zebra, low temp R404A thermostatic charge for that application. We now want to retrofit this system to R407F or maybe even R448A. Let's start by assuming we want to keep the same distributor orifice. That yields distributor total delta P's that are lower than for R404A, but still acceptable. Now, instead of 192 PSI drop across the TEV, we're going to 227 or 217 PSI. We'll see how things look if we also keep the same TEV. But wait, those aren't the same TEVs for 407A and 448A. Actually, they are. In this case, the internal diameter, the pin angle, and stroke of nominal 3-ton valves for 407F and 448A are the same as for a nominal 2-ton 404A valve. Pretty interesting there. That gives us 38 and 43% loading on these products. Not necessarily a showstopper, but pretty low enough to be of concern. Performing the same exercise for a medium temp system, we get the same relative results. We need to take a closer look at those existing R404A valves, especially considering they will have a low temp Z charge or a medium temp C charge instead of the R22 designated VC and VZ charges that would be recommended. Just in conclusion here, for this particular part of the discussion, we need to be cautious when retrofitting from R404A. What if we considered the same low temp system and again kept the same number 2 distributor nozzle, but switched to a TEV that is 1 capacity step smaller? We now have the percent loading back in the preferred range. Does the same thing work on medium temp systems? It appears that it does. So in this example, we can step down 1 size in the thermostatic expansion valve product line and move back into the preferred percent loading range and get the correct thermostatic charge as a bonus. The point here is not that we need to change out every R404A TEV in a retrofit when we're doing a retrofit to 407F or 448A, but it's to be cautious and check the sizing of the valve. Even if the percent loading is marginal, changing to a lower force, VZ or VC, that's the R22 low temp and R22 designated medium temp thermostatic charge, element construction could help regain needed superheat adjustment range, giving and yielding better superheat control in the long run. Why are the thermostatic charges for 407F and 448A the same and the same as R22? Why are they different from 404A? Well, we can tell much about what we need to know from the pressure temperature chart that we now have displayed. Since superheat is calculated using dew point conditions, it follows that superheat is also controlled from the dew point temperature. If we plot the dew point curves of these refrigerants over a range of low and medium temperature evaporator conditions, we find that R404A's dew point is several PSI higher and that of R407F and 448A closely follow the saturation curve of R22. That's what's depicted right here. That means that at a given coil outlet temperature, the R404A thermostatic charge will produce significantly more opening force on the pin than is needed. On some TEVs, there may be enough adjustment range and spring force available to overcome this. On others, there may not be. And when that's the case, you're probably going to need to change the TEV and we get to sell a new one to you. Let's consider a retrofit of a similar 1-ton capacity system, but one that is R22. Again, we'll keep the same original nozzle selected as a number 1 nozzle for R22. We see that our total delta P goes up with 407F and 448A. We expect this because we know mass flow is somewhat higher. Note though, that still leaves us with more delta P available to drive flow through the thermostatic expansion valve. We keep the same internal diameter of the port, pin angle, and stroke for R407F and R448A. And we find that our percent loading really doesn't change too much in comparison with R22. For a medium temp R22 to R407F or R448 retrofit, the results are essentially the same. In conclusion here, if we are retrofitting from R22, we're probably okay. It is still good practice to check distributor and TEV sizing. And that's really the point we're trying to make here. But we would not expect to find any serious issues. Note also that in this retrofit scenario, we can also use the same thermostatic charges on both refrigerants. Since I'm sure you don't want to listen to me go through every system component in a retrofit, we did generate this reference chart to give some guidelines to you and to alert you to things that you need to consider in retrofits to 407F and 448A and similar refrigerants. By the way, the chart is color-coded. Might be a problem for you if you're colorblind, like Heath over here, I think is colorblind. Yeah. As you can see, there's quite a bit of green, probably okay, if you will, on this chart. And there's some yellow, which indicates caution on the liquid side for 404A systems. We do have an intermix of yellow and red down here on the bottom for filters, oil, and external seal. Red means probably not okay, something that needs some extra consideration. And keep in mind, a leak-tight, clean, dry system is truly a benefit to everybody.
All right, Jim. Before I take over here, there are a couple questions here.
Oh, you got any that you can answer?
No. I think I'm going to need your help, sir.
Oh, sure.
So
what do you got?
I think we're good on time, but we have one question here. Where can I find details like net refrigerating effect for refrigerants?
That's a good question. And I'll tell you what, we are putting together another webinar where we're going to discuss the subject of what is refrigeration. And that's going to get into some of the thermodynamics of things such as that question. And I'll also post a description of this online.
Sounds good.
John, you want to elaborate on what net refrigerating effect is just briefly? You might have to come over here to where they can hear you, but you can say a little bit about that, but don't go too long because Phyllis will hit you in the back of the head.
Well, we don't want that to happen, so I'll try to be brief.
Oh, go.
Yeah. Net refrigerating effect, or NRE, is essentially the amount of BTUs available by evaporating 1 unit, usually 1 pound, if we're using English measurement, of refrigerant. And it all depends on the liquid conditions and the suction conditions, or liquid conditions into the expansion device and suction conditions out of the coil. So we can look at, if we give an example of, say, 100-degree liquid into a valve, we look at the liquid enthalpy at 100 degrees. And if we have a 25-degree saturated suction out of the coil, we would look at vapor enthalpy out of the coil. And the difference in those two is the NRE for that refrigerant at those conditions.
Thank you, John.
You're
Hey,
welcome.
we got another question here. Heath, why don't you read it? I can't quite see it from here.
All right. Are C-charge elements okay to use for low temp applications such as minus 25 degrees saturated suction temp?
That might be a stretch. In days gone by, we used to suggest that the C or medium temp refrigerant application charge was good from a minus 10 degree F to upwards of 40 or even 50 degrees. In recent times, we've learned that we can go down into the 20-degree range. 25 might be a stretch for it, though. But one thing I won't say is if you try it, you're happy with the results. I'm not going to argue with that.
All right, then.
You need to go.
All right. Well, we're going to continue with the webinar here. So just again, my name is Heath Schaefer. I'm the Controls Product Manager. I like to cover a solution that we have available, right? We were talking about mechanical solutions. We would like to cover some electronic solutions that Sporlan has to offer for refrigerant retrofits.
Oh, you mean electronically controlled?
Yes.
Okay, that's what
Thank
I
you.
thought you said. Yeah.
All right, so Sporlan offers a simplified electronic solution for these type of scenarios. The superheat control system, as shown here, also known as the SCS, is a controller that's recently released by Sporlan. This controller is encapsulated, so it can be placed in the refrigerated environment, right, without fear of moisture or any debris affecting this controller. Additionally, it was designed to be easy to install. It incorporates the temperature sensor, the pressure transducer cable, the valve cable, and also the power cable into the controller. And I'll cover more of that in a couple slides. The controller was also designed to have very simple setup using Sporlan's TechCheck app. So the user can quickly install and apply the solution to any superheat control application. The controller supports pulse width and stepper valve configurations, and I'll talk more about this in a few slides. To illustrate the example that of the scenario of the install, as I have shown here, this controller can be applied very easily. In this example, I have the pulse width version of the controller shown, and it can be used to replace a solenoid inside of a case. I'm sorry, a TEV inside of a case. In this example, the power of the controller is wired to a defrost timer. Now, that's not saying that you have to wire it there. I'm just showing that in this solution, okay? So it's the reason for that is once the unit goes into defrost, in this scenario, the unit would go into defrost, the controller itself would shut down, and since it's using a pulse width expansion valve, the valve will actually close on power loss. Therefore, you will have a positive shutoff on your evaporator. As I covered before, the setup is extremely simple, and the user will be able to select the refrigerant type, the pressure transducer type, and the superheat target, and that is all the setup that is required.
Are you suggesting that I could even do it?
I believe so, Jim.
I don't know, it's a stretch.
The SCS-SB, that is a stepper controller. It supports all Sporlan stepper valves, including our OEV unipolar line, which will be coming out soon. It'll also support our SCR, SCRI, and SCHI bipolar line of valves. So if you didn't catch that, this controller will support unipolar and bipolar valves. As seen on this slide, when you apply this controller in a retrofit application, it's going to be very simple because, again, all of those valve cables that in the past you had to buy separately, they are all attached to the controller. To simplify the install, there also supports a variety of transducers, all of Sporlan transducers, and even some external valves that you may not get from Sporlan. You can also set this controller up to support those transducers and those valves. So it's a very good, easy to use, easy to install controller.
Can you also do custom ranges and step rates with this?
Exactly what I was alluding to, Jim. So if you did have a range of a transducer that you wanted to use, maybe a 2000 PSI transducer for a certain application, you can set up the controller to accept that input. Good question, Jim. Okay, the other flavor of this controller is the SCS-PB. Now, this is a controller that supports our pulse width line of valves. As seen on this slide, applying this controller to a retrofit application is very simple, and it's based on the variety of the valves that we have to offer, and all the different transducer types are supported that Sporlan has to offer. Again, to simplify this install, the transducer sensor, the cable, the transducer cable, the valve cable, and the power cable all come as part of this package. As seen on this slide, the electronic expansion valve that this controller can connect to that are offered by Sporlan cover a wide range of tonnages. For more information and help on sizing, as Jen mentioned earlier, you can reach out to our application engineering team, and we'll have a slide later that shows how you can reach out to our team and what tools you can use to help set up and size the valves for your application and your refrigerant type.
Heath, we got a couple questions about sizing. Can we talk about those just briefly? Might be a good. Now that it looks like we've got a couple of questions about mechanical valve sizing. One asked about the use of net refrigerating effect, and the other one asked what capacity to use the size of the coil or the condensing unit. And I'll try to answer those kind of simultaneously.
Yes, sir.
Net refrigerating effect comes in kind of indirectly because something that we need to know when sizing any of our valves is what refrigerant's in the system.
Mm-hmm.
And we need to know the conditions on the high and the low side of the system. So that inherently is going to bring the concept and net refrigerating effect into play. Now, as far as the capacity that's utilized, we match the thermostatic expansion valve to the capacity or the load on the evaporator. That makes the most sense, because what does a thermostatic expansion valve do? Its sole job is to control superheat in the evaporator as a result of monitoring at the sensing bulb, wherever that's placed. So it's important to know what kind of load is going to be imposed upon the evaporator coil.
Okay. All right. Thank you, Jim. Okay. Where can the SCS be used in this type of application? Well, it can be used anywhere a mechanical expansion valve was used. So we were talking about the TEVs before. So anywhere where that TEV was used, you can now apply this electronically controlled solution. Why would you want to do that? If you're going to change, this is going to provide an advantage to the end users. It's going to provide a way to, if any time the refrigerant may be changed in the future, it's going to simplify those changes, because the refrigerant type will be stored in the controller, so you can easily move from one refrigerant to another without changing out elements, valves, or things like that. Also, if refrigerants were to come out in the future and your current controller does not support it, this controller supports the ability to doing firmware updates in the field without removing or updating or without changing out the controller. That can be done through our Sporlan Tech Check app. You can also easily change any kind of superheat setting that you want on the controller. So with the TV, obviously you have that stem that you have to adjust. With the SCS, it's as simple as opening up your mobile device, connecting to the controller, and choosing a new superheat target. You can also, this controller also gives the ability to capture the data, right? Jim, do you have the ability to capture data on a TEV?
Sure you do. You just go out there and you hook up your gauges and you put your digital thermometer on it and you sit there and read it.
Okay.
Now, what's really tough to do is to do that remotely.
Yes, it is. Yes, it is. Good point.
I have to have extra long hoses to do it remotely.
So this controller has the advantage of that it can store and keep that data for you. So if you're not there to see that problem happen, you can come back 20 days later and you'll still be able to see how that controller performed in superheat control over all of that time.
But how about Bluetooth?
So the way this controller supports and connects with the phone is actually over Bluetooth, Jim. That's how it actually talks to the controller. Yeah, believe it or not. So how can this SCS be used? Again, anywhere that there is where there is a mechanical valve, you can put this in, and obviously you want to have an electric expansion valve, and that's what it will be controlling. Okay, so it'll connect locally via Bluetooth, as I said before, from your mobile device to the controller, and you can easily make any kind of changes to enhance that control. Now what's different about this controller compared to our Kelvin 2 line, with this controller, you don't have to adjust any kind of PID settings. That is all done for you. So don't feel like you have to put this in and then spend hours adjusting the different PID settings for your different application. With this one, you go in, you set the refrigerant type, your transducer type, and your superheat type, and that's all you have to do. Along with that, you can throw away complex user manuals. My friend Jim could walk in and he could set up an SCS controller, and I would have complete confidence in that.
Wow, that's a stretch.
Okay, also along with this, you can enjoy user-friendly configurations and any future updates, as I talked about before, those will be released with the app. So if you do have a refrigerant change or you have a new refrigerant come out, we can work with you, release that in the app, and then you can go out and update your units without ripping all those controllers out and adding new ones. You'll be able to field update those control units.
Sounds to me like this is a standalone control package.
That's a very good point, Jim. It is a standalone control package. It doesn't need any external control to operate. Jim, I'll turn it back over to you.
Thank you, Heath. We've got quite a few questions that we're getting here. I'm gonna wrap up with a few more of the slides, and then depending on the time that we have allotted to us, we'll address some of them. But keep in mind, any questions that are posted online here that we don't answer, we will be preparing a Q&A blog for every single one, and we'll be posting that online. So just keep in mind, we do have a technical support crew here locally in Washington, Missouri. They can be called directly at 636-392-3906. You can also reach them by email. That's at svdtechsupport@parker.com. We have a neat software package that's available for you to use free of charge. You can find it at parker.com. There's additional resources by means of Facebook and Sporlan.com, at Sporlan.com or Parker.com. You can find technical support in the form of literature, that software package I was talking about. You can sign up for our newsletter. You can view product videos, new product releases, and the list goes on. The phone number that we have listed here is our general phone numbers for our headquarters building. You can use that to be redirected to customer service, for instance, if you need help from them, or go to tech support. And we're starting to wrap this up. Depending upon how many questions we have, we'll try to deal with a few of them. And just keep in mind that you'll be able to view this on Facebook and later our YouTube channel. And I'm just going to put one more plug in for our webinar that we're going to have on June 18th, where we cover metering devices and talk about distributors. Now, we got a few questions here that we can deal with a few. Phyllis isn't giving me the cutthroat sign. She's not cutting me off just yet. Here's a good question, Heath. It says, is there a bulletin available on the SCS controller?
Yes, there is. You can find our bulletins online at sporlan.com, Jim. We have a bulletin. We have a family bulletin that describes both units, the SCS-SB and the SCS-PB. We also have an installation and operation manual that walks you through the setup and talks about all the features related to that controller.
So they're all G-rated. You can share them with anybody. They're family bulletins.
Yes, sir, they are.
So they're not R-rated or
no,
anything
sir,
like
they're
that.
not R-rated.
There's another good question here. It says, can this EXV be retrofitted to residential HVAC? What do you say about that?
Well, Jim, can you take that one?
I'll try. I would presume if you were so inclined, you could go down that path, maybe, but probably not the best approach. I'm going to say there's other answers that are probably more appropriate than this one. It might be a stretch to try to do that with this, and you wouldn't be taking advantage of all the neat features that it has built into it. So is that fair answer to that?
That's fair.
What else do we have here?
Okay, we'll continue to look at questions. And Jim, what's going to happen if we don't get to their question?
Well, again, like I've said, because you ain't been paying attention.
I have not.
You've not been paying attention. I've told everybody that's listening, and they all could probably answer that question now. They know that I'm going to post something online with the question and the appropriate answer.
Thank you.
We're going to do that eventually, yeah. There were some other mechanical valve questions that might take some merit and take. Here's one on opening percentage. What is the minimum opening percentage of the EEV? What is the recommended operating range of some of these other valves? Now, we kind of get into some, as far as operating range on a traditional EEV, they can generally throttle down to, at a minimum, about 10% of their rated capacity. Generally, when we're talking about applications, though, you might not want to take advantage of all of that, but they will perform reasonably well down to that point. As far as maximum, I think we're talking 100% and not over that. You contrast that with, say, a mechanical expansion valve with a TEV, and that depending upon the internal construction of a TEV, we're talking about at a minimum 30% to 35% for a balanced port construction and 35 to 40 for conventional. Those numbers vary depending upon the application. We have any other questions we have time to deal with?
Sure, I can handle this one. So which EEV controller can be used for a standalone one compressor system? In that scenario, I would probably recommend the SCS-SB. That is the stepper control system. So I would not recommend the pulse valve. What we've seen in the past is that if you do have a pulse valve, you could see some water hammering effect, or we don't want the compressor to go out on low suction. So I would definitely recommend a stepper type solution in that scenario. Okay, Jim, do you see any other ones that we think we can answer in our time?
Here, let's take a look at this. This is an interesting question. All the refrigerants discussed were, it says, Freon based. Does this controller work on ammonia R717 as well?
Jim, we're going to have to review our literature on that. I don't know the answer right now.
Okay. Well, I'm going to say, as far as the products that we have coordinated it with, you know, the EEVs that we would expect that we would use in conjunction with this, they're not intended for ammonia service.
Typically not, no. I can answer another one though. The SCS controller compatible with the R440A refrigerant? Yes, it is.
Well, I think that about concludes what we're going to cover for now. Thank you all for joining us. Again, this will be posted live, or a recorded version of this live broadcast will be posted. Got me all messed up there. And we'll put a blog out with Q&A for all the questions that were given to us. Thank you for joining us.
Thank you, everyone. Have a wonderful day.